Hello everyone, welcome to Embedded Systems course with Arduino. In today's session, we are going to create the circuit which interfaces LCD 16 cross 2 LCD to Arduino, and we are going to write the code which displays certain texts on this LCD. In last session, we had covered extensively on the pin connections to Arduino, right? So you see this diagram, correct? So we said that we are going to connect LCD to Arduino in a 4-pin configuration, right? So which means that we are going to use 4 data pins, right? D4, D5, D6 and D7, and connect to 4 pins of Arduino, right? And we are going to use the resistor select and the enable pin also connected to Arduino. Rest of the pins of the LCD, of this VCS, VCC and VE can be connected to some ground or high voltage 5 volt pins which are supplied to the breadboard from the Arduino, right? And similarly for this backlight, right? These two pins, right? This one and this one, we discussed that this was for backlight. So this also can be connected to the voltage and the ground pins respectively, right? So that this will serve our function, right? To simplify it, we will only connect the data pins, we will connect these 4 data pins, right? And the resistor select and the enable pin to Arduino, right? So let's move over to Tinkercad and start designing these circuits. Okay, so if you see here, right, I have already started creating a new design where I clicked on circuit and opened a new platform page to create this. Right now, the new component here for you, which you have to take is LCD. So if you take here, you can have to take LCD 16 cross 2, which I have taken, and put it on this breadboard, right? Also, you can view the detail, that in the detail view you can also get this information about this LCD, right? So this is one thing which you can get. Now as you all know, right, we have connected, first we have taken the breadboard, right, and we have given the ground, right, and the 5 volt supply to these two rows of the breadboard, right? So this is now at 0 volts, the black wire, right? This row, minus row, and this plus row is at 5 volts, right? So now basic thing what we have to do, we are driving only 6 pins from Arduino, right? The 4 data pins and the resistor select and the enable pin will be driven from the Arduino. Rest I told that we will sub connect ground or voltage 5 volt supply to the other pins, right? So if you see here, right, this is VSS, which we said that this is our ground pin. So this we will connect from ground to this column, right? So this is at now at uh, ground, right? Now this you see is a power, right? So we are connecting 5 volt supply power. If you see, if you go over these pins, it will show contrast. It is actually in real time it is connected to a potentiometer, but you can also connect to ground, right? So this is your contrast. Now what is this? So this is your resistor select. Now resistor select will be driving from the Arduino, right? So we will connect to pin number 12 of Arduino, and we can take pin number 11 for our enable pin, right? So let's take this, let's connect. We are connecting pin number 12, right, to the resistor select. So let's connect, right? So it's connected, right? Now what is this? This is your read and write. So we are writing, right? We told that we have to provide two informations, the command register, the instruction information, and the data register information, right? So we are writing, we are selecting 0. So 0 has been, ground has been supplied to this pin, right? Now this is enable. Now let's, what we will take, let's take 11th pin of the Arduino and drive the enable. Okay. So taking the 11th pin and connecting to, right? So enable pin of this Arduino, of this LCD, right? So now this 12th pin is connected to the resistor select, 11th pin is connected to the enable, right? So now what we do, now these uh, this is DB0, DB1, DB2, and DB3. We are connecting in 4-pin mode configuration, right? I told you. Because the only difference is that in 4-pin mode, it will be a bit slower, since to send 1 byte of information, you have to send it 2 nibbles twice, right? And in 8 byte, you can, in 8 bit, you can send all together, right? So this is faster. Now we will connect, right, to the 2, 3, 4, and 5 pins. You can select any other output pin also, right, of the Arduino, and drive this data pins, right? So let's start connecting, right? So we will take this, right, and let's connect DB4, right, to pin number 5 of Arduino, right? Now pin number 4 of Arduino, we will connect to DB5, right? Pin number 3 of Arduino, we are connecting to DB6, and pin number 2 of Arduino, right, we are connecting to DB7, right, the data bus 7th pin of the LCD, right? So now, right, so now the data pin connections are made, right? So we are going towards the right and connecting all the pins. Now what is this? Now this is your LED anode and this is your LED cathode, right? So we have connected a resistor from the ground towards this and a 5-volt supply towards this, right? So we similarly we saw it in the diagram also in the slide, right? How we have to connect this. Now our connections are done, right? We took a 4-pin mode configuration, connected the 4 data pins, and we connected the resistor select and the enable to the LCD pin interface. So now all pins are connected, right? So now what we have to do, now we told that now let's go to the code part. Okay, so in the code part, you see I told you very first that since we are writing a C++ based code environment, in a code environment, right? So what we do, we include the liquid crystal display library, right? So once we create an object of the liquid crystal type, then we can use all the inbuilt functions of this library. Okay, so that is what we will do. We have included the library code hashtag include liquid crystal dot h, right? Now what I told you that we will create an object, right? So what we have done, we have created an object here. If you see, right, create an LCD object of type liquid crystal, right? So this is what we have done. Liquid crystal LCD, resistor select, enable D4, D5, D6, D7. And we told that the resistor select is connected to the 12th pin of the Arduino. Enable is connected to the 11th pin. D4 is connected to the 5th pin. D5 to the 4th. D6 to the 3rd pin of Arduino, and D7 to the 2nd digital output pin, right? This is how the connection is made. And we saw in the syntax that liquid crystal of a liquid crystal object LCD, right, will provide this RS enable D4, D5, D7. So ultimately we are passing the Arduino pin information or the pin numbers to this LCD object, right? So this part is clear, and this we need to do before using LCD in any of the creating embedded systems or writing the code, right? So this part is common. Now I told you we need to initialize the LCD, right? One time display. So one time any initialization we will of course again do in the setup task of this Arduino code environment, right? So what we do LCD columns and rows, right? So 16 columns, right, and 2 rows. So this is initialization, set up the LCD, right? So this initialization has been done, right? Now what we do, now let's suppose we have to print hello world, right, to the LCD. So we can use the print command of the LCD object. Print will be included from this library which we have included in the top, and you can mention LCD hello dot print hello world, right? Now we put a delay, right? And what we are doing is now we, okay, so if you leave this also, what we do is we are now scrolling, right? If you want to scroll one bit, one character towards the right, right? So what we are doing is 0 to 16. Since there are 16 characters in a row, we can scroll one character towards the right, one bit at one character at a time, right? So that is what we are taking, a position counter 0 to 16, and just incrementing one by one, right, towards the right, and asking the LCD to scroll the content towards the right. But that will happen after a display delay of 2000 milliseconds, right? So this is after 2 seconds it will happen, right? Now, okay, so now after a delay of 150 milliseconds, it will again keep on position moving or scrolling the character, one character at a time towards the right. LCD clear, this will clear your screen, right? So you will, this will clear the screen, right? Now set cursor, what we are taking, so the objective of this code what we are writing is, you display the hello world, then after some time you scroll it towards the right, right? So this is what it is doing, this part of the code, right? So this will scroll the content, which is hello world in our case, towards the right, right? And then you will clear the screen. And what we are doing, we are counting how much time the LCD has been on from the point of reset. Like once we have given the power supply, how much time the LCD has been on, right? And I told you that we can do, so you remember, right? We have this millis function which counts the number of milliseconds, where we can provide and count how many seconds have expired, right, from the time the power supply was provided to Arduino. So this is what we are doing, okay? So now if you see here, right, so this is what we do, we set the cursor at 60, right? So sixth column and the 0th row, right? So sixth character position and the 0th row, this cursor will be set, and it will write count, right? So, and post that, this is one time it will happen, and then it will keep on counting, right? So now counting, what we want to do, we want to display the count in the second row, right, in the down row, right? And it should increment, and it should display the number of seconds which have expired from the time the Arduino has been powered on, right? So this is, and so this should go on a loop, we are writing that code in a loop, right? So this is what we are doing, right? So now let's run this, okay? Let's see what happens, okay? So if you see here, this hello world scroll towards the right and count is increasing, right? So I told you count we are writing onto the sixth column, right? Sixth column, 0, 1, 2, 3, 4, 5, sixth column, 0th row. And in the second row, right, we are setting the cursor at this point, right? 8th position, right? And then we are incrementing the time which has expired from the point the Arduino was reset or has been powered on, right? So this is what we are doing. I will stop this, right? And I will just, to show that first we'll see the hello world print, we'll wait for 2 seconds, then it will scroll towards the right, right? So see, hello world was there, it will wait for 2 seconds here, it is scrolling towards the right, then the count will be displayed, and the time expired will be incrementing on the second row, right? So this is what the code was also written, right? If you could see here, right, we are dividing by 1000 because this millis tells us the number of milliseconds, and dividing by 1000 gives us the number of seconds, right? We have set this cursor, and this cursor position is the one which is incrementing here, right? So this is in general the code. I hope every function is every use of the function is clear, right? So once again, I'll just summarize this, right? We initialized the LCD, created an object of LCD, a liquid crystal type, which was called as LCD, right? Then we initialized it, right, in one time setup, right? We printed hello world, waited for 2 seconds, right? Then we scrolled it towards the right, right? One character at a time. Then we cleared this hello world, right? We cleared the screen. We set the cursor somewhere at sixth position, sixth column, zeroth row, right? And we wrote count. Then our intention was to count the number of seconds that from the time the LCD was on, right? So what we do, we took the millis function, right, which counts the number of milliseconds, right? I told you in the very first session with LED, when we are interfacing LED, millis is used, right? So we divided by 1000 to get the number of seconds, right? And that we display it, right? So this is what this task was doing. And in similar way, you can interface the LCD, right, with Arduino in a 4-pin mode, right? Hope all of you have understood this. Thanks for joining.